Discuss the convergence of the integral 0 to 1 x raised to n minus 1 log x dx. Solution: I equals to integral 0 to 1 of x raised to n minus 1 log of x dx. We know limit x tends to 0 plus 0 x raised to power p log of x equals to 0 when p is greater than 0. So the given integral is a proper when n minus 1 is greater than 0, that is n is greater than 1. When n equals to 1, I equals to integral 0 to 1 of log of x dx equals to limit epsilon tend to 0 plus 0 in integral epsilon to 1 of log of x dx equals to limit epsilon tends to 0 plus 0 x log x minus x limit epsilon to 1 equals to limit epsilon tends to 0 plus 0 minus 1 minus epsilon log epsilon plus epsilon equals to minus 1. So I converges when n equals to 1. When n is less than 1, let f of x equals to x raised to n minus 1 log of x, taking g of x equals to 1 upon x raised to power m. So f of x upon g of x equals to minus x raised to power m plus n minus 1 into log of x. So limit x tends to 0 plus 0, f of x upon g of x is 0 if m plus n minus 1 is greater than 0. Taking 0 is less than m is less than 1, and also m is greater than 1 minus n, which implies 1 minus n is less than m is less than 1, or 1 minus n is less than 1, or n is greater than 0. But integral 0 to 1 of g of x dx is convergent. So integral 0 to 1 f of x dx is convergent. So integral 0 to 1 x raised to power n minus 1 log of x dx is convergent for all n is greater than 0. Further, taking m equals to 1, also m equals to 1 minus n, m is less than equal to 1 minus n, that is 1 is less than equal to of 1 minus n, which implies n is less than equal to 0. But for m equals to 1, integral 0 to 1 g of x dx is divergent. So I diverges for n is less than equal to 0. Thus, for the given integral converges for n is greater than 0 and diverges for n is less than equal to 0.